Greetings and welcome, friends. Mr. Waddy here. Today, we are going to take out some of the bigger guns. We're going to solve the same types of problems, being systems of linear equations, using a more accurate and more powerful, more precise means than graphing, right? And you can already just tell that I'm much more excited about this than solving by graphing. So this is what we've got. Solving by substitution. So it solves the same kind of problem using a different technique. And yes, I'm going to need you to know all of the techniques that I show you. All right. So unfortunately, you can't just pick like, well, I like this one, I'll just use this one all the time. We got to know how to use all of the techniques. All right. So solving by substitution will be used to solve a system, right? When I have two equations and two unknowns, right? An x and a y, or whatever variables I might have. So solving a system, right? Previously, we would have graphed these and found their intersection. Not necessarily accurate, not great when it's far away from the origin for the solution. All right, but for substitution, actually, let's just jump right in. I don't think it makes sense for me to read the steps. We'll just do the problem, and I'll reference the steps. Okay. So here's my two equations. One of them happened to be in slope-intercept form. The other one didn't. It actually doesn't matter to me. All right. And I'm going to solve this. Substitution is using algebra. So you guys are hopefully going to be good at algebra. So what's step one? Step one says solve one of the equations for one of its variables. So one of the equations for one of its variables, not necessarily y. So look at this equation. This equation has a y and it has an x. The y has a coefficient of 1. The x has a coefficient of -2. The second equation has an x and a y. The x has a coefficient of 6. And the y has a coefficient of -5. Now, when solving by substitution, my recommendation is this. And this is also the book's recommendation. It's actually nice that they were willing to be so clear about it. Target the weak spot. All right, you're looking for the headshot with the sniper rifle and Halo is what we're doing here. I don't want to aim for all of this body armor with the -2, the -5, and the 6. Don't bother. You want to aim for one of the equation's variables that has a +1 or even a -1 coefficient, because then you'll be able to avoid a lot of fractions and you'll make the problem easy for yourself. So when doing this problem, I am going to target this y, right? That's where I'm aiming because it has a +1 or -1 coefficient. Now in this case, step one is already done. It's actually already solved for that y, right? Y equals -2x minus 9. Now, like I said, we love solving for y, but sometimes you'll want to solve for the x. So this one happened to be a solve for the y step, and it was already solved. So step one is done. Step two, now it says substitute the expression from step one into the other equation and solve for the other variable. All right, actually, super key word is other equation. All right, if you don't plug this into the other equation, you will end up falsely coming to the conclusion that there are infinitely many solutions. So let's see. So step two, if y equals -2x minus 9, all right, if that's what y is equal to, then according to the substitution property, I can actually plug in that expression for y in the other equation. By other equation, I mean this was the equation that I solved for starters. The other equation is the one that I did not. All right. And now if y is equal to this, that means I can replace it with this entire expression. This is referred to as the revised equation. All right. Revised equation. And I'm going to plug this expression in for the other equation's y. So I'm going to write 6x minus 5 parentheses -2x minus 9 equals -19. All right. Let's see. All right, guys, I think I'm going to show myself on the screen here. Let's see, can I? Aha! All right. So you guys, my real life friends, you can look back here and follow along. My internet friends can actually see me down here on the screen. I'm like showing up in the corner. You just can't see me on. What I want to show you about substitution is, and you guys, so you can just look at me. In the first Indiana Jones movie, okay, Raiders of the Lost Ark, great film, great film. He goes through like this little, forest jungle, and he comes to this cave, and him and his buddies are going to find like some archaeologically significant statue, like it's this little golden idol. And he goes through this cave, and there's all these traps, right? So you guys remember what I'm talking about? Anyone ever seen it? Maybe not. Okay. Well, anyways, he comes to the room, and in the room is the statue is like on a pedestal, all right, and like there's this floor, and there's like these spike spears that shoot up from the holes in the tiles of the floor. So he's got to like play like don't touch the rocks, or don't step on the lava game, where he's like walking only on the safe squares from one to the next. And then he finally gets to what he wants, which is, in my case, is the red pen, and in the movie's case, the little golden idol. And he thinks to himself, okay, if everything up to this point has had traps, I'm assuming I can't just like take the thing that I want. And so during the scene, he has a bag full of sand that he had previously gathered, okay? And his thought is this, that if he takes the bag of sand and it weighs the same as the golden idol, what if he could swap them just perfectly, and then not set off any trap that's based off of the weight of that object resting on that pedestal? All right, substitution is at play. And so what he does is he takes an object that he assumes is of equivalent weight, and he does this thing, and his little buddies in the background pretending to swap the sand for the golden idol. And so this is what he does. He goes and he swaps them, right? And that was so tense. Did you guys see that? That was like wobbling and rotating. And he messes it up, all right, because Indiana Jones probably didn't know like the number of moles of gold that were in the golden idol, and the molecular weight of gold at an atomic level, and the bag of sand. So he probably messed up. But his theory was sound, that if those were the same, he could have substituted them at either point, and it would have worked out just fine, right? So that's the idea. Substitution. So when we go to our problem, which is over here on the screen, right? All right, over here on the screen. Let's see, I'm going to shut off my video. Bye, friends. Bye, internet friends. Wow, that was the first time they've ever seen me on these series of lessons anyway. So when we go to this problem, all right, if y is really equal to this, that means I could plug it in. I could substitute it up here, just like my sand for the golden idol. And remember, Indiana Jones did not just like throw a pile of sand on the pedestal when he grabbed the golden idol. He put it in a bag. And so when you substitute here, notice I put this in a nice bag that keeps the sand all together in parentheses, okay? In parentheses. And by doing so, I think you guys would agree, this equation looks uglier than either of the original two equations. None of the original two equations had parentheses, right? This one's a lot longer than the other two. But this equation has one benefit. Notice, it only has one type of variable. It only has x's. There are no more y's in this equation. And that's why for step 2, right, we substituted the expression from step 1 into the other equation, and I'm going to solve for the other variable. The other variable being x. All right, there's only x's in this equation. So let's solve for x. Let's do this. So I'm going to distribute here to simplify. And that's why those parentheses were so important. If you don't put the sand in a bag when you put it on the pedestal to stake the golden idol, you're going to mess it up. So be careful. Put it in those parentheses. So 6x, negative 5 times negative 2x is plus 10x. Negative 5 times negative 9 is plus 45 equals negative 19. All right, are there any like terms that I can combine? Does 6x have any friends? 6x and 10x, perhaps? is going to be 16x, right, plus 45 equals negative 19. All right, let's scroll down a little bit. I'm solving for x still. All right, still on step 2. Subtract 45 from both sides. Oh dear. Oh boy. I'm going to have 16x equals, let's see, negative 45 minus a 10 would have been negative 55 minus 9. Is that negative 64 perfectly? I think so. And how do I solve for x? I got to do one more thing. Both sides. Divide by 6. And so this is super precise. Even if these had fractions or weird square roots or whatever, I would have gotten exactly the value of x every time. Every time. Todo de los tiempos. Okay? I just, right, solved for x. Now this is half of my solution. Because my question is, what is the x and y combination that makes both of those equations true? And I've got half of my solution. So now that brings us to step 3. Let me show you step 3. It says substitute the value from step 2 into one of the original equations and solve. I'm actually going to even suggest into the revised equation, which in this case, that ended up being the same as that. But the benefit is that this will be less work a good amount of the time. All right. So our revised equation was this. All right. I know what x is equal to. X is equal to negative 4. And we're going to substitute again. I'm going to plug negative 4 in for x in the revised equation. I'm going to do step 3 right next to these. I think I can fit it. If you guys need to work vertically, you can, but so I'm going to have y equals negative 2, and instead of x, I've replaced it with a bag of sand. It's negative 4, right? So negative 2 times x minus 9, right? And the benefit of plugging it in the revised equation is this equation is already solved for the other variable. So all I'm going to have to do is just like PEMDAS this. Negative 2 times negative 4 is positive 8. Minus 9, and positive 8 minus 9 is negative 1. So my solution is x equals negative 4, y equals negative 1, or you can write that as an ordered pair, negative 4, comma, negative 1. All right? All right, all right. So it's a little bit more work, but it's precise, and it works every time. All right, let me see if I can cruise through 2 more examples here. Let's see. Yeah. Actually, do you guys want to see a graph of this just to verify it? Like, you want to just me to Desmos graph this real quick to see if it actually intersects at negative 4, negative 1? Let me do that. All right, y equals negative 2x minus 9. All right, let me clear out these guys. So let's see. Let's do that. Y equals negative 2x. What was it? Minus 9? Did I get that right? Negative 2x minus 9. And the other one was 6x minus 5y equals negative 19. All right. So here's the intersection of my 2 lines. And notice, let's see. Negative 4, negative 1. That's exactly what I said. So if I did solve this graphically, I do get the same answer. So both of those equations represent 2 lines, and there's one combination of them that makes both of them true. Cool. All right. Let's do another example here. All right. Nothing too crazy. Nothing too crazy. So I'm going to do monitoring progress question 1. What this is. All right. Solve the system of linear equations by substitution. Step 1. All right. Who should I target? Where is the weak spot? All right. The first equation has an x and a y. Which one's weaker? Which one doesn't have body armor? Which one doesn't have shields right now? The y, because it's got a positive 1 coefficient. In the second equation, oh wow, I actually have two choices. This one doesn't have any any coefficient other than 1 or -1. So for step 1, I could solve for this y or this y. Doesn't matter. I don't know. Let's do the first one, I guess. So I'll have y equals -3x plus 14. Step 1 is done. Like that. That was it was already done for us. Oh, good catch. Thank you. Thank you kindly. Yeah, with the save. All right, so here's substitution. If y is equal to that, then I could replace y with that in the other equation. And that's what I'm going to do. All right, so I'm replacing y with that expression. So instead of y, I'm going to write 3x. All right, let me actually label this as step 2. 3x plus 14 equals -4x. Now, in this case, the bag of sand, the bag wasn't that important because the y wasn't being multiplied by anything, right? It didn't have like a number out front that would need distribution. If you wanted to throw parentheses there, you could, but I think it'll just confuse us. So how do I solve for x? Well, let's bring the x's together. I could move the 4x over here, but it looks like it might save me a step if I just deal with a -x. Yes, that's fine. So let's see, 14 equals -7x, and then divide by -7. And I'm going to flip it around. X equals 14 divided by 7 is 2, and there's a minus sign, so it's negative. Voila. All right, but that's only half of our answer, folks. I now have to take this and substitute it in for x in the equation from step 1. All right? Step 3. Question? Or no, you're just stretching? Just stretching. All right, I'll work vertically so that if you wanted to do, I know you guys have question 2, monitoring progress 2 next to this. So let's see. So I'll have y equals 3 times, but instead of x, I'm going to write -2. 3 times -2 plus 14. And so y equals -6 plus 14. I get y equals 8. And so the solution of this problem is the ordered pair -2, 8, x, y. Super precise. Zero graphing. Right, just my algebra skills and Indiana Jones and Halo all combined into one. Right, this is the sniper rifle method. Super precise, right? Gives you the solution. Works even when your solution is super far from the origin. It'll give you decimals, fractions, radicals, whatever you need. And in general, we want to aim for the weak spot, right? We want to aim for the variable that doesn't have a coefficient that's visible, right? 1 or a -1. Let me do example 2. This one will be a little bit more interesting, and I think that might be all we need because I want you guys to have some time to practice this. All right, example 2. All right, solve the system by substitution. All right, I like this one because this one actually doesn't have step 1 done for us. All right, so you see this problem, all right, this system, we've got 2 unknowns, and we've got 2 clues, 2 equations to help us find those unknowns. We suspect there is one combination of x and y that will make this equation true. Where's the weak spot? If you see this problem running across Blood Gulch, across the map, where are you aiming on this problem? Right, where do you lock on? For step 1, we solved one of the equations for one of its variables. Which variable are you targeting? Which one do you want to target? Let's see. Any of the y's are good, right? Because those have positive ones. This x is also good because that's got a -1 coefficient. You don't want to aim for the 3x because that's going to create fractions. It'll take a little bit more effort. You'll work through some fractions in order to solve it. So let's solve the first equation. And in this case, I'm actually intentionally going to target the -x. I know I would actually prefer to target a positive one, but we've been solving for y's all day. I want to solve for an x for once. So negative x plus y equals 3. To solve for that x, how do I get y away from it? Subtract y from both sides. That have the opposite of x equal to the opposite of y plus 3. And then I can just go through and change everybody's sign, which I do by either multiplying everybody by -1 or dividing everybody by -1. I just say, let's opposite everything. So here is what my revised equation is. So now the thought is that if x is truly equal to y minus 3, then I should be able to plug this in. Now, wait a minute. Where do I plug it in? Do I plug it in this x or this x? What was the step? It said substitute the expression from step 1 into the other equation. All right, other equation. Other equation. So, what do you guys think? Which one's the other equation in this case? Well, I solved the first equation this time, so the other equation is going to be this one. So I'm going to plug it into the second equation's x. Has to be the other equation. Must be. All right, so 3 times, and instead of x, I'm writing y minus 3. And then plus y equals -1. So notice x in its entirety has been replaced by y minus 3. And now I've got one equation. It's a little bit uglier, but it only has y's in it. It only has y's for you? Yes. I was just thinking of a song, only have y's for you, but yeah. Now we're good. Do some distributing here. 3y minus 9 plus y equals -1. Combine like terms. 3y and plus 1y is how many y's? How many y's, guys? 4y minus 9 equals... Oh, okay, yeah. Yeah, there are 2 y's drawn. Yep. Add 9 to both sides. Ooh, this one's not going to have a fraction answer. But if it did, it wouldn't matter because my sniper rifle is super accurate. It'll give me fraction answers. Hardly any effort. And then divide both sides by 4. And so I get y equals 2. That's half of my solution. What was step 3, guys? Do you remember step 3? What do I do? How do I find x now? I plug this number in to the revised equation. Now I could very easily, I could have plugged it in for either of these, and that's fine. The reason I like the revised equation is that this equation is already solved for x, so I won't have to redo any algebra to make that happen. Okay, so I'm going to have x equals y minus 3. So y is 2 in this case. So x equals 2 minus 3, which is -1. And when I write my solution, remember that it's in the ordered pair x comma y. So it's going to be -1 comma 2. All right. So there we go. We'll have a part 2 video tomorrow on solving by substitution. Have a great day.